All right, everybody, welcome. And today we're going to be talking about glycolysis. And what I want to start off by doing is talk a little bit about just the general numbers of things that we're going to end up with. So, the sort of products, if you will. So, what we're going to start off with is glucose. And the glucose is going to be broken down into pyruvate, right? Pyruvate. Right? And then what we're going to generate is ATP and NADH. But first we have to invest a little bit. And what we're going to invest is 2 molecules of ATP. So 2 molecules invested. We'll call this the investment phase. Okay? Investment. And then what we're going to do, after we've done a couple of other things that we'll describe in more detail in a little bit, what we're going to do is generate sort of a payoff, or the energy payoff phase, and that is where we're going to get 4 ATP, right, and 2 NADH. And remember what those are the high energy electron carriers. Right? And we call this phase over here the payoff phase. So we have an energy investment phase, which is over here, and we have an energy payoff phase, which is down here. And we're going to talk about that in greater detail. Right? So let's kind of dive right in and get a sense for when it is that we're going to generate all these different molecules. Let's start over here real quick. We have, again, glycolysis. And that occurs in the cytoplasm. And what glycolysis is the breakdown of glucose into 2 molecules of pyruvate. And I should put a 2 down here just so we remember that we're making 2 of these. Alright, so what we're going to start off with, if we can look at our image from your book, we're going to start off with glucose molecule. I know it's hard to see, but you can use the copy from your book sort of in line with this. But what we're going to start off with is 1 molecule of glucose, which is 6 carbons, and we're going to end up with 2 molecules. See the little 2 right there, right there, and we're going to have 2 molecules of pyruvate, which is 3 carbons. So 2 times 3 is our 6 carbons that we start with. Right? All right. So what we've done is we've broken it down into both of those phases. So the top phase up here is our energy investment phase, and the phase down here is the energy payoff phase. So what's going to happen is we're going to have a whole host of reactions that occur, and then this split here. We'll talk about this in a second. And then we'll continue way down over here, and we continue along, and now we start to pay off. We get our NADH here, and we get ATP here, and another ATP here. Understand that right here we have 2 molecules going through. So we go from 1 molecule to 2 molecules. All right, let's break that down just a little bit of detail, not too crazy detail, but a little bit more than maybe we've seen before. So we're going to start with our glucose molecule here, and that is 6 carbons. And that glucose molecule is converted into another molecule called glucose 6-phosphate. And really what you need to understand is that we are going to use ATP, and what we're going to do is we're going to use ATP and we're going to get ADP out of it. And what's happening is that third phosphate group gets added to this molecule right there. Right? So we call that phosphorylation. So we're phosphorylating our glucose molecule into a molecule we call glucose 6-phosphate. Alright, so that costs us 1 ATP. Now we're going to have a couple of other little reactions, and on this what we call the third one, we're going to phosphorylate again. So we're going to add another ATP, and we get ADP out. And we're going to skip this reaction. We're just going to breeze over that. But what we're going to focus on is this ATP here. So now we're in the third step here. And what's happening now, we have 2 phosphate groups on this guy. And these are high energy functional groups that will provide the energy necessary for all this other stuff that we see at the end here. Alright, so now what we have is, it's called bisphosphate, and that means it's double phosphorylated. So that's this guy right here that we won't really name. It does have a name. It's fructose 1,6-bisphosphate. And what we're going to do now is we're going to split that into two molecules. So this is our splitting part. Okay. And it's at this point that we can actually give these names. You don't have to know these, but this one over here, is actually called dihydroxyacetone phosphate. Now, we normally just refer to that as DHAP. You don't need to know this, but I want you to understand a little more detail. That's important because this molecule needs to get converted into this molecule over here. So what is this molecule here? That is glyceraldehyde 3-phosphate. Now this one has a name. We just refer to that as G3P, glyceraldehyde 3-phosphate. Right? So these two molecules are important because now these can kind of transfer back and forth. But what's important is to follow the G3P. G3P is going to do some cool things. That's going to help us transform this molecule into pyruvate. Should be noted that when we went from this molecule here, the bisphosphate, this molecule is now, or these molecules are now 3-carbon molecules. So 3 carbons. We've gone from our 6-carbon here to 3-carbon here. Alright, so our first reaction is going to end up with a little bit of payoff. We're going to end up reducing NAD plus into NADH, so it is reduced, meaning it's going to gain an electron. Right? And then what we're going to do, we're going to continue on this path here. We're going to have another reaction here, and what that reaction will do is it will release one of those phosphate groups, and it will give us ATP. And I'll get to the numbers here in a second. Alright, and then we have 2 more reactions. I'll just draw little bitty arrows here. 2 more reactions that we aren't going to really follow at this point and have to learn. But then our final bit here is where we make pyruvate. Right? And right here we're going to release another ATP. Alright, so if you're with me here, we notice we have 1 ATP and 2 ATP. But wait, I said 4, right? Well, remember we have this DHAP. So it's at this point that the DHAP gets converted into G3P, glyceraldehyde 3-phosphate, and it goes through this pathway. So we have 2 molecules of pyruvate that are made. These molecules each have 3 carbon. And then we release an NADH and an ATP and another ATP. So in this case, 2, 2, and 2. So we can go back to our sort of catalog of the numbers here when we're marking down how much of each one. We can see 4 ATP, 2 NADH, that is in our payoff. So it's a grand total of 2 ATP and 2 NADH. Remember, those are the electron carriers. Okay, I hope this helps. We broke it down a little bit more detail, not too much more, but really want to focus on, again, identifying the numbers of these molecules that are important as far as energy goes, and then later on we'll go through the next couple of steps and you'll identify the importance of following the carbons, right? So we're going to follow the matter and follow the energy. All right, hope this helped, and I'll see you in class.